In continuation of the previous video, I'll talk about the mapping of a zero. Okay, a mapping of a zero, which is over here. Okay, which is what we have derived earlier. Let's don't care about this one first. Okay, let's talk about the zero first. Okay, let's continue from the previous video, but rather than in a more deeper way, such that we know that the s itself, this s value, can be re-represented in the Euler's formula r cosine theta plus rj sine theta, right? This one, and we know that we can plot all the interval from 0 to minus 2 pi is going in the clockwise direction. Correct? Now, what if we have s plus 4? Right, this transfer function now is s plus 4. We know that s is simply this one, correct? And we have proved to you that it's being drawn in this manner. If you have a plus 4 in this case right here, the 4 itself is a real value, correct? And therefore, this real, meaning not imaginary lah. If you remember, this is the real axis, this is the imaginary axis. So if you have plus 4 in the real axis, this means you are shifting the graph by plus 4. So in other words, the new graph is just to shift by plus 4 in the real axis. You see? So you're going to shift over here, and the new graph will somewhat look like this. With the same form of a clockwise direction. Okay, so we can generalize this 4 as just plus a, some real number, and that's it. And then, what is the meaning of mapping then? What's the true meaning of mapping? The true meaning of mapping, you will just go back to this one, okay? If you were to split it up, okay? If you take a look over here right now, alright, this thing over here is what we have drawn over here. Alright, this graph, this nice one graph, alright, is simply at the right hand side. Is this one, okay? While this orange color one, which is s plus a, is this one, okay? So just now what we have drawn is like that, right? What we have drawn is somewhere like that, right? I'm just taking this graph, I plot it over here. That's all, simple as that. Okay, if you don't get the meaning. So in other words, I'm taking this point and I plot it over here. So in fact, this point will have plus 4, right? Because s plus 4 ma, right? So each of this point will have plus 4. So you're plotting each of the point, all of this point, plotting it all over here. Okay, and this is in fact called the mapping. Okay, over here right now, although this is called mapping, but the true meaning isn't being shown quite explicitly or obviously in this example. Alright, later on I'll just show you what's the reason behind that. Okay, but what I want to convey is that in this scenario, this is simply s. It's just simple s, alright, which represent our Euler formula, the cosine theta, r cosine theta plus j sine theta. So simple system like that. Just that this graph over here, right here, helps you to plot your zeros. Alright, you have s plus 4, and therefore I plot my zeros over here. I'm just simply plotting a 0. Alright, when you plot your root locus is where you plot your zeros and your poles over here, and then you visualize, right? This is just simply plotting the 0. When you plot already, alright, the angle between this x and the y axis is simply this, and this is the angle. And we are very concerned about the angles between this 0 to each of this point right here. To each of this point, we are concerned of this angle, and this angle all depends on the position of your 0. Right, if you were to position your 0 in, for example, if I were to position my 0 over here, Alright, this is my 0 where the function g of s is equals to just s. Alright, this is for s plus 4. Alright, and therefore if I have an s, then this angle over here, alright, correspondingly to each of this point is different already ma, right? Why is it different? For example, this magnitude is maybe what is this? This is 5 lah, for example. Then this magnitude is -2. Okay? By definition, -2 over 5 O over A is equals to tangent theta. Right? If I were to find theta, this angle is simply -21.5. Okay? If I were to do this, the distance over at this side is much longer, which is somewhat 9 and -2. If I were to find the same angle, I mean find using the same method, I would have somewhat -18 or 15, I forget, but somewhat you have a different angle, and this is why the portion over here is very important, the concept over here. This thing, this circular ball over here is always the same, going in the clockwise for a 0, right? For a 0, it's only when you plot at different points of the 0, then relative to each of this point, you will know that the angle is all different, and it's very visually explicitly defined, and such that the mapping itself I want to convey is that it maps onto the side. It translates each of this point to the side. Okay, I don't go through in detail, but in terms of for any transfer function, the 0 is simply to translate your initial graph over here, right here, how many times to the right or to the left, that's all. Alright, you'll not go up, okay? So you'll just go to the right or to the left. You may go up, but in our case we don't go up first, okay? It's just only translating in this direction or in this direction, that's all. That's all, okay? That's all. So this is just a simple understanding of pole mapping. Alright, zero mapping, okay? It's 0 mapping. So in the next video I'll talk about pole mapping, and I'll see you there.